All right, good afternoon, folks. My name is Dave Riedmiller. I'm the Director of the National Climate Assessment at the U.S. Global Change Research Program. Welcome to our session on the fourth National Climate Assessment, Volume 2, Impacts, Risks, and Adaptation in the United States. I believe we have some hard copies of the overview and report and brief in the back of the room. We've got a bunch more at the booth, the USGCRP booth in the exhibit hall, so please do make sure you stop by, see us, talk to us, let us know what you think. We've got a really fun panel today. I'm going to start off by kind of giving some context for the National Climate Assessment, and then we're going to turn it over to a couple of the real experts that actually wrote the report. The first of which will be a video by Catherine Hayhoe, who fortunately, unfortunately, is on her way back from Oslo from the Nobel ceremony. And that'll be on the climate science aspects, the physical science aspects. We'll then hear from Jeremy Martinich, who is the lead author of the mitigation chapter, talking about economy and infrastructure, before turning to Patrick Gonzalez, the lead author of the Southwest chapter, who will talk about ecosystems. Then we'll hear from Chris Ebi, the lead author of the health chapter, and then Victoria Keener, the lead author of the Hawaii and U.S.-affiliated Pacific Islands chapter, to talk about regional perspectives writ large. And then we'll end with Meredith Muth, who will focus on the international aspects of the National Climate Assessment. The first time these were really integrated in a concerted and kind of explicit manner. And we should have adequate time in the end for questions, so please hold your questions to the end, if at all possible. But we'll be around, at least most of us, I think, at least for the rest of the day and through the week. So without further ado, I'll go ahead and get started. The National Climate Assessment, as many of you probably know, was part of a piece of legislation that was passed almost 30 years ago, the Global Change Research Act of 1990. That legislation established the U.S. Global Change Research Program. And part of that also mandated that we conduct a quadrennial assessment that did three things. The first was to kind of assess the findings of the programs, look at the impacts of climate change across the United States, a number of different sectors, and then also look at projections out into the future, both on multi-decadal and centennial timescales, both human-induced and natural aspects of global change. So what we just released was our fourth National Climate Assessment. This cover may look familiar because that was the big news last November. This was Volume 1 of the fourth NCA. You can check it out at science2017.globalchange.gov. If you're in IPCC parlance, this is the equivalent of Working Group 1. And you've got about, 500 plus pages or so across 15 chapters of the physical science of climate change across the United States. A couple of important advances that were characterized in this report include, in particular, aspects of detection and attribution of anthropogenic climate change, with a focus on various extreme events, obviously pertinent now: floods, wildfires, droughts, that sort of thing. And of course, our cover image, as well as our booth background image, atmospheric rivers, which have increasing importance now in the wake of the California wildfires. Another big advance was the large-scale incorporation of downscaled information. This allowed us to really hone in a bit more on what's going to, or what is expected or projected to happen at a more local level. And the final chapter of the report is probably one of the most interesting in the sense that it covers some topics that aren't typically in climate assessments, and that it looks at potential surprises. So how are different tipping points and thresholds potentially going to interact with one another? How are different systems going to respond in ways that may have unintended or unexpected consequences now? This whole 500-page report was summarized in about it was supposed to be a 20 to 30-page chapter, but I think it became, 50 to 60 pages. Nonetheless, it's a great summary. And again, we've got copies of this as well at our booth. But what we're going to talk about today is mostly Volume 2, the Impacts, Risks, and Adaptation Assessment. This was released just a couple of weeks ago. And like all of the USGCRP products, we remain policy relevant without being policy prescriptive, again, similar to the IPCC mantra. I mentioned the increasing availability of downscaled information, which really allowed us to put a big emphasis on the regional information, which you'll hear about from Victoria a little bit later. That was in large part as well in response to stakeholder needs and demands for more local information to inform decision making, especially when it comes to adaptation. We also have a lot, for the first time, integration of economic impacts and quantifying impacts in economic terms. A big advance, albeit in emerging literature, but a very important one that we're pretty proud of to have incorporated, and you'll hear Jeremy talk about that. We also, again, in response to some public comments, have a more holistic and explicit integration of international issues. So Meredith Muth will cover those aspects. And what we did was really look at a range of potential impacts. If you're thinking about what's going to happen in the future, we don't know what the future is going to look like. It depends on how the Earth responds. It depends on how humanity evolves, and it also depends on what natural variability is going to look like in the next couple of years and decades as well. So looking across a range of impacts allows us to inform decisions in a more complete manner. And we also wanted to really highlight a number of case studies. People are really starting to respond to climate change, and we wanted this to be, a report that not only tick, 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 tick all these impacts, but really says, you know what? People are starting to do stuff about this. We can start to grapple with some of these issues, and there are great stories being told across the U.S. So we'll talk a little bit about those. I put this slide up not with the intention of you being able to read every detailed point, but really to highlight that this is a beast of a process. It's and for good reason. I mean, this is the nation's authoritative, comprehensive assessment of climate change, and in order to do so and to do so in a credible way, you need a process that is robust, that is inclusive, that is transparent. And we like to think that we've accomplished all of those objectives, and part of that is through kind of a very extensive and intensive process that involves multiple points of federal decision-making, review and comment, a lot of public engagement, which I'll talk about in the next slide, and a lot of work from the 300-plus volunteer authors that stuck with us through the past 2.5 years, which we're incredibly grateful for. I mentioned public engagement was a key component. It started back with feedback on a draft prospectus that we released, I think, in the summer of 2016. That kind of informed the development, some initial thinking in terms of guidance. We had a public call for authors in the fall of 2016 with a simultaneous and extended call for technical inputs to make sure we were aware of everything that's going on out there. We then conducted a big series of regional engagement workshops across the U.S., which you can see the map of on the right-hand side here, the 10 NCA regions, the big green dots illustrating where we had our hubs of these REWs, on the smaller green dots are the satellite locations. And we, in large part thanks to in-kind contributions from universities, think tanks, and other partners, federal agencies, were able to accomplish something really pretty impressive that reached literally thousands of people across over 40 cities in a matter of 3 months to pull in a lot of information, not just what is going on the ground, what's the latest literature, but what is it that's important to you? What kind of assessment do you want that's going to be responsive to your needs? And that's really what we're trying to do here. We then took all that information, wrote a draft report, sent it out for public comment to National Academy's review, and had to have a call for review editors to make sure that the authors responded to each and every single one of those public comments and the National Academy's comments, which totaled close to, I think, 4,000 for the public comments and a 200-page review of the National Academy's. And you can see all the comments and the responses on our website if you're that kind of glutton. So all of this public engagement led to the report that you see here, basically. I mentioned we have a number of national topic chapters and a couple of new ones, including a new chapter on air quality that really built out of the USGCRP Climate and Health Assessment that was released in 2016, looking at the nexus of air quality and climate change issues. A new chapter on climate effects on U.S. international interests. Again, I said Meredith will talk about that. But it really kind of brings in an element and a perspective that had heretofore been lacking a little bit from domestic work. And then there's another really interesting chapter on sector interactions, multiple stressors, and complex systems. This kind of builds off of the food, energy, water nexus chapter from NCA 3 to really look at some of the kind of latest developments in the integrated assessment modeling community, and in particular, as I mentioned a little bit earlier, how some of these different climate impacts might interact with one another. How does a mountainside that has been stripped down from wildfires respond after an atmospheric river hits it, causes a landslide, and cuts off public health services to a rural community? These types of things you might not initially think of as a climate impact, but as you read the report, you'll see examples of this sprinkled throughout, and they're captured really well in this chapter. The bulk of the report is focused on regional chapters, as I mentioned, and this was again in response both to public demand for that kind of information, but also where the science allows us to go with all the new downscaled and localized information. We made a concerted decision to pull the U.S. Caribbean out of the Southeast region, so there's now, for the first time, a standalone chapter for Puerto Rico and the U.S. Virgin Islands for a couple of reasons, one of which, of course, is because they're a unique geography, but they also have, they're exposed to unique vulnerabilities and have a unique capacity to respond, frankly, as we saw in the aftermath of Hurricane Maria and Irma. We split up the Great Plains region as well, so you've got a northern Great Plains and southern Great Plains region, so you don't have one region spreading from Canada to Mexico. A couple of response chapters, and then a suite of appendices as well, as I mentioned. One of the big things we tried to focus on in this report, and with I think a lot of initial nervousness, both on the part of USGCRP as well as the authors, was to really write in a risk-based context, a risk-based framework. This is not typical scientific writing. If you've read through the National Climate Assessment, hopefully you've seen that. And what we really wanted to try and do was to say, think about what you care about. What is it that your stakeholders care about? What is it that the public cares about? What do they value? What do people in the Southeast care about? What do people in the Northwest like about their lives? Are these things going to be impacted by climate change? If so, how? And what sorts of impacts do we want to avoid? These are the types of questions that we ask the authors to consider in the development of their chapters. And so when you look at the type of scenarios you can consider, the program made the concerted a decision early on in the process to focus on two primary scenarios in an effort to provide a bit of an envelope for decision makers when they look forward into the future. You want to look at both, a scenario that could have pretty extensive and widespread impacts, but also one where we might actually take some near-term aggressive mitigation action. So we looked at both RCP 8.5 and 4.5 primarily. Finally, I'll just, penultimately I'll say, in 5 bullets, we've got a 1,500-page report, but if you want to know, the take-home message is that climate is now changing faster than at any point in modern human civilization. These changes are primarily the result of human activities. The impacts of climate change are already being felt across the country by every community in almost every aspect of life. But Americans are responding, There are good stories to tell, as we mentioned. Unfortunately, neither global efforts to mitigate the causes nor regional efforts to adapt to the impacts currently approach the scale needed to avoid substantial damages to the economy and American health and well-being. So with that, I would just want to highlight a couple of events that we've got coming up over the next 2 days the rest of the week that might be useful. Tomorrow morning at 8 a.m., we've got a poster session where each of the 30 chapters, 29 chapters, and a number of appendices will have posters, so please do come by, interact with the authors. It'll be a great way to dig into the content of the report a bit more intensely. Tomorrow afternoon, we've got an early career session to try and grow the assessment community by trying to attract some early career folks into the process a bit more. And then on Friday, we have both an oral and a poster session looking at how communities across the U.S. are actually using not just the National Climate Assessment, but state and local and regional assessment efforts as well to inform decisions. And of course, come by the booth. USGCRP would love to meet you, talk a little bit more about what we do, and thank you again for coming. We'll save questions till the end of the program. And we're going to turn it over now to a video that Catherine Hayhoe, as I mentioned, who was unable to be here in person, produced on the climate science aspects of the report.
Hi, my name is Catherine Hayhoe, and I'm going to be introducing the climate science that underlies the 4th U.S. National Climate Assessment. I really appreciate the chance to be able to give this talk virtually because they haven't quite figured out teleportation from Norway to Washington, D.C. yet. But I am going to be giving my presentation on Thursday in person, so I hope to see you there. As you'd expect from the National Climate Assessment, our first conclusion was pretty basic. Global climate is changing rapidly due to human activities. It's the same conclusion that we've come to in every single National Climate Assessment. But today, of course, we have some updated numbers. First of all, global average temperature has increased by nearly a full degree Celsius, or 1.7 degrees Fahrenheit, from 1901 through 2016. This is a very rapid pace compared to natural variations in the history of Earth's climate. Since the 3rd U.S. National Climate Assessment was published in 2014, that year became the warmest year on record globally. It was soon surpassed by 2015 by a wide margin, and then by 2016. So all told, 16 of the last 17 years have been the warmest ever recorded by human observations. Not only that, but observational evidence does not support the idea that these changes are natural. As you can see here, natural changes cannot account for the warming that we have observed over the last century. Rather, the evidence consistently points to human activities as the dominant cause. Future warming depends on human emissions, as well as on the Earth's response. With significant reductions in emissions, the increase in global temperature could still be limited to 2 degrees or below. However, if emissions continue to climb, annual average global temperatures could increase by more than 5 degrees Celsius or more than 9 degrees Fahrenheit before the end of the century. The world's oceans are changing too. They are absorbing about 93% of the extra heat that's being trapped inside the climate system by all the heat-trapping gases that we're producing. They're also absorbing more than 25% of all the carbon that we produce as well. And this is leading to declining oxygen concentrations in many coastal areas. By 2100, we expect average sea surface temperatures to increase by nearly 5 degrees Fahrenheit or 2.7 degrees Celsius. We also expect that oxygen levels could drop by about 3.5%, and global average surface ocean acidity, due to absorbing all those carbon emissions, is projected to increase by 100 to 150%. This is a level we haven't seen in at least 66 million years or more. As you'd expect, global sea level is rising as a result, both because the water is warming as well as the fact that land-based ice is melting. So far, we've seen about a 7 to 8 inch or 16 to 21 centimeter rise since 1900, but almost half of that rise has happened since 1993. So of course, we expect sea level to continue to rise by at least 1 to 4 feet by 2100 relative to 2000. But new science regarding the instability of the Antarctic ice sheet suggests that under a higher scenario, we can't rule out higher amounts of sea level. As much as 8 feet or 2.4 meters by 2100 is physically possible, though we can't assess the probability of such an extreme outcome yet. These changes are affecting climate right here in the United States. It's affecting temperature, both average and extreme, and it's affecting precipitation by season as well as by extremes. So for example, across the US, annual average temperature in the contiguous US has increased by about 1.2 degrees Fahrenheit over the last few decades. Over the coming century, we expect about 2.5 degrees Fahrenheit or 1.4 degrees Celsius over the next few decades, regardless of future scenario. But beyond that, the increase could be anywhere from 3 to 12 degrees Fahrenheit, or 1.6 to 6.6 degrees Celsius by end of century, depending on whether the world follows a lower or a higher future scenario. Changes in average temperatures are affecting our extremes as well. One example is the ratio between the number of extreme high temperature records and the number of extreme low temperature records that are set every year. If climate isn't changing, we'd expect that ratio to be about 1 to 1. Today, though, it's currently about 2 to 1. We're breaking on average twice as many high temperature records as cold ones. Precipitation across the U.S. is changing in many ways. First of all, annual precipitation since the beginning of the last century has increased across most of the north and eastern U.S. Over the coming century, we expect the biggest increases to happen in winter and spring across the northern part of the country: Alaska, the northern Great Plains, the upper Midwest, and the Northeast. But perhaps even more importantly, how precipitation falls is also changing. We're seeing it falling in more extreme events. So for example, since the 1950s, we've seen major increases, especially in the Northeast and the Midwest, but really across all of the country. This is expected to continue in the future, and as temperatures warm, we also expect to see surface soil moisture decreasing, and we expect to see large continued declines in snowpack. This is a concern because it supplies much of the water for the western United States. As it gets warmer, more winter precipitation shifts from snow to rain, and unless new reservoirs are built, much of that precipitation is lost. Why do we care about a changing climate? It's because it's loading the dice against us. It's taking what used to be entirely natural risks and it's amplifying or exacerbating them. We see this in our high temperature extremes. We see this in our heavy precipitation. And we're concerned about it because we find that in some cases, especially like for extreme precipitation events, climate models tend to underestimate the observed trends. We're seeing major changes up in the Arctic. Up there, annual average temperature has increased twice as fast as the global average. It's accompanied by many more changes that are visible to the naked eye: thawing permafrost, melting glaciers, loss of sea ice. In the future, this is expected to continue. By mid-century, it is very likely that the Arctic could be nearly entirely free of sea ice in late summer. We also see that permafrost is expected to continue to thaw. And we care about that because, of course, it has a lot of carbon and methane trapped in the permafrost that would be released as it thaws. And these are powerful heat-trapping gases that would amplify human-induced warming. Atmospheric circulation patterns are also changing. First of all, the tropics are expanding poleward. This is pushing the northern hemisphere winter storm tracks northward as well, and a shift in those storm tracks has been observed since the 1950s. We're seeing changes in the frequency and the severity of landfalling atmospheric rivers. Narrow streams of water that transport water vapor thousands of miles across the Pacific to the western coast of the US. And of course, hurricanes and tropical cyclones are also being affected. In the future, specifically, we expect the rainfall and the intensity of these tropical storms to increase. At the local to regional scale, ocean circulation is also affecting sea level rise, as is changes in local subsidence or uplift of land. So because of that, regional changes in sea level rise and coastal flooding are not evenly distributed around the US. Since the 1960s, sea level rise has already increased the frequency of high tide flooding, or sunny day flooding, in other words, there's no storm, it just floods, by a factor of 5 to 10 for many US coastal communities. And in the future, these type of sunny day flood events are expected to continue to increase. The primary concern related to ocean circulation is the potential slowing of the Atlantic Ocean meridional overturning circulation, or the AMOC. If it slowed down, it would affect the polar transport of heat. And this would in turn affect regional climate as well as exacerbating sea level rise along the eastern coast of the US. Observational data has not yet been sufficient to determine if the long-term slowdown has absolutely begun, but one recent study found a 15% weakening since the mid-20th century, and another one found a weakening over the last 150 years. Over the next few decades, it's very likely that this circulation will continue to weaken. It might eventually stabilize under a lower scenario like RCP 4.5, but under a higher scenario, it would continue to decline. And then there's this, that there is a huge potential for future surprises in the climate system because we have never pushed the planet this hard, this fast. Carbon dioxide concentration in the atmosphere has already passed 400 parts per million. This level was last seen about 3 million years ago. And at that time, global average temperature and sea level were significantly higher than today. If carbon emissions continue to grow over the century and beyond, it would lead to an atmospheric concentration that hasn't been experienced for tens of millions of years. And our present-day emission rates of nearly 10 gigatons of carbon per year suggest no climate analog for this century in any time in at least the last 50 million years. The climate change that's resulting from human-caused emissions will persist for decades to millennia. And why we're concerned is because it could be enhanced or amplified by self-reinforcing cycles within the climate system. These cycles have the potential to push the Earth's climate system into new states that are very different from those experienced in the recent past, and extremely different from anything we've seen over the history of human civilization on this planet. Future changes outside the range of climate models can't be ruled out. And because climate models have a systematic tendency to underestimate temperature change during past warm paleoclimates, it's more likely, unfortunately, that the models might underestimate future long-term change than overestimate it. So what does the future hold? We can't make predictions of what's going to happen over the next century. But we can say that if we want to have a certain chance of keeping global average temperature at or below a certain level, then here are the cumulative carbon emissions that we can produce. So, for example, if we want to limit temperature rise to at or below 2 degrees C, then we have a 66% chance of doing so if we keep cumulative carbon emissions at or below 800 gigatons. What does that mean? Well, if global emissions follow the lower RCP 4.5 scenario, this would give us about 20 years worth of emissions before we hit the limit. Unfortunately, however, the observed increase in carbon emissions over the past 15 to 20 years has been more consistent with higher scenarios. So what's the bottom line? The bottom line is climate change is real. It is us, and it is serious. The impacts, as the National Climate Assessment documents, are here today. But the future truly is in our hands.
So again, thanks to Catherine remotely. We'll have some of the authors for that for that chapter in the audience. So if you do have questions after at the Q&A period, they'll certainly be able to handle them. I'm now going to invite Jeremy Martinich up. He's like I said, the lead author of the mitigation chapter. He'll be talking about economy and infrastructure in the National Climate Assessment.
Thank you very much. Thank you, Dave. It's a pleasure to follow Catherine Hayhoe. It's usually a tough job, but a professional video of Catherine Hayhoe seems almost unfair. But I will nonetheless try my best. So taking all of the physical climate impact information that Catherine just reviewed coming out of the assessment, I want to talk a little bit about what the assessment finds with regards to impacts and risks and the vulnerability of our economy and the infrastructure within our country. And so coming out of the third National Climate Assessment in 2014, there was a call for more information on impacts and risks across different sectors and how looking at the difference between scenarios can, what that means for impact sectors like infrastructure and being able to quantify economic impacts and risks across these different sectors. And so with the explosion of a lot of new studies in science and economics in that space, there was a lot for the assessment authors to draw on, which is somewhat new. And so we can answer some of these questions of, what are the economic risks that are known or understood to be projected for across the regions and sectors of the U.S., and how might emissions mitigation as well as adaptation change those risks. And so I'll report out and about some of those findings. So from the transportation chapter, this should be a review for most of us. The impacts of climate to our transportation infrastructure are very complex, obviously very diverse. Changes in thermal effects like heat can buckle rail lines, can change the freeze-thaw zone, can place our infrastructure in climates that it was not designed for. And that creates the excessive wear on our infrastructure. It requires additional maintenance and quicker replacement and potential failure. So the effects of heat, sea level rise, heavy precipitation, and other climate effects can be very complex, as reviewed in this chapter. And so Catherine just talked about the effects of sunny day flooding or nuisance flooding or high tide flooding on coastal development. And this analysis here, again from the transportation chapter, reviewed and analyzed impacts of high tide flooding on the road network and delays associated with that, with those impacts. And so you can see that with higher levels of sea level change, 3 scenarios are shown here, as well as 3 sort of time periods over time. You see a progression of increasing delay hours, even under an intermediate scenario, pretty significant amounts of delays for coastal roads by the end of the century. So here I want to switch to labor. This was included in the Southeast chapter. This is an analysis looking at impacts of climate change on the provisioning of labor, so that looking at impacts to high-risk populations, so the high-risk industries that are exposed to the elements more. So you'd think of agricultural field workers, construction workers, roofers, people who are outside. And so this is an analysis looking at both positive and negative effects. I'll actually show a figure from the underlying literature where that's the same map we were just looking at. That's under a higher emission scenario, RCP 8.5 in 2090. But if you can see mid-century and under the lower emission scenario. And you can see pretty large reductions, as you'd expect, in labor across all of the country, particularly in the South, modest benefits along areas of the Pacific Northwest. This can have a very significant economic effect. So the 2 analyses I just focused on did not include adaptation, which is potentially relevant for those sectors. But in the coastal sector, this figures from the coastal chapter, we know that adaptation has historically been a response, and one important for including and modeling into the future. And so this is an analysis looking at impacts of sea level rise and storm surge on coastal properties, determining the timing of the vulnerability of these properties, and then trying to estimate a response based on the value of the property, whether you would consider protecting that property or not. And if you did protect it, how would you protect it, and what are the cost implications of that protection? So interesting coming out of the study was that, as you can see, these are discounted economic values, a stream of discounted economic values over time. So the difference in the RCPs is not great. And if you remember that sea level rise graphic that Catherine showed, you would have seen that the difference between the sea level between the scenarios for sea level rise doesn't really diverge until sort of 2060 or so. So that leads to a delay in the effects of looking at differences in the RCPs. That delay is then affected pretty heavily, further heavily by the discounting. But you can see here the real storyline is that adaptation is really important. Now this happens to be a very near economically optimal adaptation scenario, so it's assuming that adaptation is well timed, and we know that our history has shown that adaptation in the U.S. has not been well timed. We continue to be battered by storms and have very significant impacts. So, I think that it's safe to say that, reality could be somewhere in the middle here. Regardless, we're talking about a case where, we're making very significant economic investments to protect coastal property, or we're facing an outcome which is significant losses of coastal communities. So another unique advancement in the in the sort of economic literature has been a series of projects. I sort of show some findings from two of them here that look at impacts across a number of sectors. And so these are where a number of modeling teams have gotten together, run their sectoral impact models using very consistent and similar sets of scenarios and inputs, and in the result is that we have very sort of more apples-to-apples comparisons across sectors and regions. And that's really important when you want to consider and answer questions about, what in my country is potentially the most economically damaging sector. You might want to ask that question in your region or in your state or in your county. And there's more and more information to try to answer some of those questions. You may also want to know, what does a large level of global emission reductions mean for my sector or for my region? And so with these types of modeling frameworks, you can begin to answer those questions. And so here, this is a figure from the mitigation chapter 29, showing, and you don't need to really focus on the specific details or the numbers, but rather you can use this information across all of these sectors to again identify where the vulnerabilities, economic vulnerabilities, potentially the greatest, and what does emissions mitigation, global levels of greenhouse gas emission reductions, what does that mean for that sector? How much of those potential impacts under a high scenario could be reduced or avoided compared to a scenario of significant greenhouse gas mitigation. And so this is, I think, a significant advancement compared to previous climate assessments where the literature now supports this type of information, and hopefully it's a space for additional exploration and inclusion in future assessments. So now these are the findings from another sort of multi-sector assessment that was done by the Climate Impact Lab, a group of modelers. This is a figure that this right panel was reproduced again in the mitigation chapter of NCA 4 based on a study that was published in Science. And with this left panel, you can see this is very similar to the graphic that Catherine just showed, for three different RCPs or emission scenarios, the amount of emissions under each. And then the right panel here is the potential or projected impact across 6 different sectors in terms of economic damages compared to current levels of GDP. And so you may have seen in the week following the rollout of NCA 4 that the media focused a lot on this 10% damages, or climate change is going to damage the U.S. economy by 10% estimate. And so that came from this figure. I would say that was a slight mischaracterization of what certainly the assessment stated, as well as what this study found. You can see, let me first echo that, regardless, this figure shows pretty significant impacts to the U.S. economy. We're talking about, in almost all cases, 1 to nearly 4.5% of GDP. So very significant economic impacts. Again, these authors focused on 6 sectors: agriculture, labor, heat wave mortality, energy, coastal, and crime. So, again, as this literature evolves and deepens, I think there will be a further exploration of looking at not only how do impacts play out in more sectors, so adding to sort of the quilt of what we know, trying to hone in on some of these questions of what does adaptation mean for this sector? How could a combined response of adaptation and mitigation reduce these risks? And so with that, I will move along.
Thank you, Jeremy. Great stuff. We've got Patrick Gonzalez coming up now. Patrick is going to talk to you about ecosystems throughout the National Climate Assessment.
Burning flames towering above a home in Thousand Oaks, California. Just as wildfires have overwhelmed many communities across the United States in the past few decades, published research that was assessed by this National Climate Assessment has shown that old policies have combined with human-caused climate change to substantially increase wildfire across the United States, even if wildfire is a natural process. Healthy ecosystems conserve biological diversity and also provide for human well-being, providing us with safe forests, clean water, and economic livelihoods. But human-caused climate change is damaging the integrity of ecosystems and their ability to provide for people. So today I'm going to summarize some of the insights of the National Climate Assessment on how climate change is, is increasing risks to the ecosystems that sustain us in these 4 sections. And first, the historical impacts. All of the examples that I'm going to show you have gone through these 2 procedures, detection and attribution. So all of the examples in this section will be changes that mainly or in part are due to anthropogenic climate change. Historical data on wildfire, including this very wildfire, the Rim Fire outside of Yosemite National Park, and historical data on climate has shown that climate change has doubled burned area across the western United States since 1984. And this analysis comes from an analysis that ties vegetation aridity to climate, and then burned area to vegetation aridity. And consequently, the loss of vegetation cover often removes the protection of the watersheds that can provide a steady and reliable stream of clean water to us. In the Colorado River Basin and in California, precipitation bounces up and down year to year, high interannual variability. But recent very dry years have coincided with century-high temperatures due to climate change to produce severe droughts. Consequently, Lake Mead here has dropped to its lowest level since the lake was filled decades ago. And Lake Mead and other reservoirs like this provide for drinking water for cities, irrigation water for agriculture. So a direct impact on human well-being. In the Colorado Rockies and across the western United States, climate change has doubled tree mortality due to 3 processes. 1, increased drought. The 2nd, increased wildfire. And the 3rd, increase in bark beetle infestations. Bark beetles have erupted to their greatest extent in the western U.S. in 125 years because winters are less often cold enough to freeze and kill the beetles during winter. Glaciers form unique ecosystems, and they also provide us an important service of locking up the water on land in ice so it doesn't raise sea level. Now, this is Muir Glacier in Glacier Bay National Park, Alaska. Look at the, if you look at the top of the glacier here against the mountain, this is in 1941. Look at the glacier, 63 years later. So that's before 1941 and after. At its lowest extent, Muir Glacier has lost 640 meters of ice. That's about 2,000 feet or greater than the height of One World Trade Center. And this is just one glacier among many that have contributed to this result that climate change has caused 2/3 of the ice melt since 1991. That glacial melt has combined with the expansion of ocean water when it warms to raise sea level about halfway to your knee in San Francisco and all the way to your knee in New York City. A hazard, of course, to urban areas, but also inundation of wetlands and other natural ecosystems. And the heated water of climate change has bleached coral reefs here in American Samoa, in the U.S. Virgin Islands, and in Hawaii. Remarkable, diverse ecosystems being devastated. Climate change is shifting warmer conditions in the winter farther north, and consequently, winter bird ranges have been following that farther north. And as a result, at least one species, this evening grosbeak, has disappeared locally from northern Michigan and the northern United States because it's actually at its southern edge here in the United States, and so it's shifting back up into boreal regions in Canada. In Yosemite National Park, in Alaska, in the Green Mountains in Vermont, climate change is shifting major vegetation types, biomes, either upslope or towards the poles. And this is a major change in the ecosystem. It's in these cases, it's a change from alpine meadows to subalpine forest, or trees moving onto formerly treeless tundra in Alaska. Those were all historical impacts, and now I'm going to summarize some of the projected future risks if we don't reduce our emissions. The loss of suitable climate could increase natural species extinction rates to up to 5 times historical rates, including the polar bear, one of the few species listed under the U.S. Endangered Species Act as threatened in part due to climate change. The increased aridity of climate change threatens higher mortality, higher death of trees and many plants, including Joshua Tree in its own, in the national park named for it. The warmer and moister conditions of climate change favor many invasive species, including this Japanese knotweed not far from here in Rock Creek Park, but also Burmese python in Florida, lampreys in the Great Lakes, and cheatgrass in Idaho. Warmer water is a hazard to salmon, trout, and other cold water species, both in streams and rivers, but also in coastal environments, the marine heat waves. Obviously, bad for the ecosystem, but also for fishers and others who depend on fish for their livelihoods. The warmer, moister conditions of climate change also increase the potential growth and spread of mosquitoes and other disease vectors, including the tick that carries Lyme disease here in the Lehigh Valley, Pennsylvania. And continued climate change could increase wildfire frequencies by up to 6 times in the United States, not just in the western U.S., but increasing wildfire in the east also. Wetlands protect coastal areas. They buffer coastal areas from storm surges. But a combination of sea level rise and land use change, and in this case, levees along the Mississippi River that prevent sediment from replenishing the wetlands, has led to a loss of wetlands and their buffering capacity. The dissolution of carbon dioxide in ocean water creates a weak carbonic acid naturally, but too much carbon dioxide is dissolving corals and shellfish. So I'm going to zoom through now the adaptation measures. A couple of examples. Adaptation for natural resource management is basically a change of resource management goals from trying to make things like they looked like in the past to planning for what they might look like in the future. And prescribed burning here to protect the sequoia groves in Sequoia National Park is one example. And another example is raising heat-resistant local corals in these underwater nurseries in Florida, Biscayne Bay, and in the Caribbean also. And the climate assessment, we made a great effort to harvest these ideas so that local people can learn from adaptation measures across the country. So these are some of the diverse adaptation measures covered in the report. The cause of climate change is carbon pollution from human sources, cars, power plants, and deforestation. And so this section is about directly attacking the cause. And ecosystems provide a natural means to do this. Of course, vegetation naturally removes carbon dioxide from the atmosphere. And forest conservation is an effective measure both to improve ecosystem integrity, but also to reduce potential climate change. And the coast redwoods have the highest carbon per unit area on the ground. And one mark of this is the 27 national parks in California, all told, so including the redwoods and the sequoias. All of that carbon adds up to 1 year of emissions of 7 million Americans. So that sounds like a lot, 7 million Americans, everybody in those cities, Los Angeles, Boston, Charlotte. But actually, it's not a lot because it's only 1 year, and in 1 year, we can burn off all of the equivalent of all the carbon there. So that really points to the importance of emissions reductions from fossil fuels. The climate assessment has several examples of real benefits to ecosystems from reducing fossil fuel emissions, and one of them is for coral reefs. And so the difference between the purple area, widespread, almost complete loss of coral reefs, and then that middle blue area, that's the difference between no emissions reductions and emissions reductions that are more than today, substantial but possible. Also, emissions reductions could reduce potential extinction rates by up to 60%. That's a comparison of RCP 8.5 to RCP 2.6, and the roofer red knot is another species listed under the U.S. Endangered Species Act as potentially vulnerable, threatened, in part due to climate change. And now we come back where we began, wildfire, and reducing greenhouse gas emissions from RCP 8.5, the highest scenario, to a lower scenario, 4.5, could reduce wildfire risk in California by half. It's certainly a great challenge, but in conclusion, I want to remind you that we have been making progress towards this during the 8 years of the Obama administration. The United States reduced its greenhouse gas emissions 8%. And even today, the 16 states of the U.S. Climate Alliance and Puerto Rico have cut their emissions 14% and are on track to meet the Paris Agreement goals. So we have so individual sustainable actions do add up, and emissions reductions can help save the ecosystems that sustain us. Thank you.
Thank you, Patrick. Beautiful, if stark imagery. We've got our next talk by Chris Ebi, who will be talking about human health across the National Climate Assessment. Yeah, there's stairs in this way.
Well, thank you everyone for coming this afternoon. It's great to see such a great turnout. All the previous presentations were really, really excellent. I'm filling time because the mouse is dying, and
Anyone got some double A's?
can I do it from here, just pushing forward?
It's not up on the screen. So.
Oh. I think we're going to need some IT person. Oh, look at that. Actually, the mouse should have died in the previous presentation while you're talking about ecosystems. Well, let's see how this goes. Oh, it's connected.
There we go.
All right, look at that. So as you heard, I'm going to talk a bit about the human health chapter. And first, I really wanted to thank a stellar author team. People worked very hard on putting together this assessment, worked very collaboratively in going through a significant body of literature and coming up with some key findings that we hope will be not only of interest, but useful. So the first key message is similar to previous national assessments and to international assessments, is climate change is affecting the health of Americans. We have more confidence in this statement than we did in previous assessments. Previous assessments talked about the well-known relationships between weather and climate and our health. One thing that's changed is there's now detection and attribution studies for health, showing in fact that people are suffering and dying from climate change right now. And you can see in the figure on the right, there's lots of drivers, that it's fairly complicated in health to determine the extent to which climate change is affecting particular health outcomes. That there are a range of other factors that are important. When you think about vector-borne disease, for example, that climate change can affect the ecosystems within which you find mosquitoes and ticks. They can affect how people behave in terms of going out into forests and then having encounters with those ticks. There's also a range of socioeconomic factors that are quite important in looking at these interactions. So it is an area where there has been a challenge in conducting detection and attribution studies, and we can now say that those are done. We can start seeing a signal in the noise. And unfortunately, as the climate continues to change, the expectation is we will have more detection and attribution studies and show, in fact, that there's more health outcomes being affected by a changing climate. When we look at the health consequences of a changing climate, we're talking about a very wide range of health outcomes. This is a nice slide put together by CDC, where in the center you see some changes that create exposures that are important for health. And then on the outside, you can see the long list of health outcomes that we're looking at. When you talk with departments of health and with ministries of health within the United States and around the world, this is just about everything that a ministry needs to deal with. So the mandate is quite broad. It also creates challenges because when we look at our health systems, we have programs for vector-borne diseases that are separate from programs for waterborne disease, that are separate from programs that look at undernutrition, that are separate from programs that look at maternal and child health. So climate change cuts across all of these issues and is going to be a driver in how public health responds. It's going to push our health systems into an integrative approach that is much needed in the short term and it will be critical in the longer term. And it's not just the health outcomes, it's our health systems themselves. That many of our critical facilities, hospitals, healthcare services are in coastal zones that are subject to sea level rise and storm surge. When you look particularly in the Pacific at the American affiliated Pacific Islands, when you look at Hawaii, when you look all along the east and the west coast, we have far too many facilities that are vulnerable themselves. And so there's a lot that needs to be done in basic triage of what particular facilities can be saved, what could we manage over the shorter term by making some adjustments, and which are going to have to frankly be moved. So this is a graphic that came out quite recently talking specifically about the health facilities. And so we need to think about both. Most of the work done in earlier assessments focused on the health outcomes without focusing on those facilities. A second key message is that vulnerability is differential across time and across space. We do have populations that are much more vulnerable than others. They're often, excuse me, they're often marginalized populations. They're the poor. They live in places that are less desirable. So they have a double burden in essence of living in a location that's more vulnerable itself, and then living in communities that have fewer resources, human and financial resources, to be able to adapt to a changing climate. And so you can see on this figure some of the communities that are of importance. We've got communities of color that fall into the categories I mentioned a moment ago. When you look at heat, older adults are particularly at risk during heat waves. Children also are at particular risk during heat waves. They're also at risk for a wide range of respiratory outcomes because children breathe more air relative to adults because of their size. And there's low-income communities. And so as we understand more about the health risks of a changing climate, we're getting better understanding of the range of communities that will be differentially affected. And of course, that varies from place to place across the United States. And so this is an issue that came forward quite clearly in the regional chapters in better understanding which communities in which locations are more vulnerable than others. A third key message is that adaptation reduces risks and improves health. And this is both for the health outcomes and for the health facilities. This is a graphic that is in the report, and it shows two locations, Charleston County, South Carolina, and Miami-Dade County in Florida, just showing the facilities that could be subject to flooding if there are different categories of hurricanes. As we've seen in hurricanes across the United States in the last few years, that facilities are not prepared. That when you go into a hospital, most of the critical infrastructure in terms of electricity, in terms of generators, are in the basement. They're not flood-proof. And so we saw in Superstorm Sandy that there were critical care patients being carried out by hand because there was no electricity in hospitals, that they had to intubate some of the children when they carried them out. So there's a lot that we need to do to make sure that we can ensure that our facilities are ready for these kinds of events. And by and large, they are not. There's also lots that can be done in terms of the health outcomes. There's an enormous opportunity in health to start using the massive amounts of environmental data that many of you in this room helped collect. There's been limited efforts to use that other than for heat wave early warning systems. And frankly, for the heat wave early warning systems, the emphasis has been on establishing thresholds and not really looking at the responses and making sure responses are effective. In this, you can see on the top, when we have outbreaks of a variety of infectious diseases, you see this kind of normal shape curve. And historically, there has been efforts with passive and sometimes active surveillance to try and detect when first cases occur, and the response comes sometimes later. This was put together by Corey Morin. I think Corey was being a bit optimistic about this, that when you look at previous outbreaks, often the first case wasn't detected until after the peak of the curve, and response is on the downslope. But early warning and response systems can move that information backwards. There's a number of examples around the world, for example, dengue fever carried by a mosquito called Aedes aegypti, and can move that detection of when we've got the right environmental conditions back by several months, which gives a real opportunity for health systems to go out and clean up breeding sites, warn pregnant women to protect themselves against being bit, and a whole range of issues. So that time is really critical, and there's real opportunities to be able to do this going forward using environmental information. Our fourth key message is reducing greenhouse gas emissions results in health and economic benefits. That most of the mitigation policies and technologies have benefits for health, and those benefits are now. That we do not need to wait for the benefits of reducing our emissions to reduce impacts on the climate. If we can get more people out of cars, getting less emission from tailpipes, reducing emissions from coal-fired power plants, get more people walking and biking, all of these have benefits for health. The benefits are quite large, and the benefits are basically immediate. The estimates of what the size of those benefits are when you calculate reductions in hospitalizations, reductions in premature deaths, that many of the estimates suggest that the benefits of mitigation for health are of the same order of magnitude as the cost of mitigating. So this shows you one study that was done for the end of the year looking at extreme heat mortality in just 49 cities, and you can see a big difference in RCP 4.5 and 8.5. If you turn that difference of under 6,000 deaths, if you estimate, for example, that each death, the value of a statistical life, or how you value a death, is about $6 million per person. You multiply that by 6,000, you can see that just in these cities, there's a very large benefit. And so there's more work that's going to be done in the space, but there is lots of good information that can help with understanding, helping populations understand why mitigation is so important. And with that, we've got acknowledgments for our various very helpful people in the USGCRP, and I'm done early.
Next up is Victoria Keener, the lead author for the Hawaii and U.S. affiliated Pacific Islands chapter.
Good afternoon. So unlike the other speakers up until this point who have concentrated on the sectors, I'm going to be talking about all of the regional chapters. As Dave said originally, the meat of the National Climate Assessment this time around was really on the regional chapters. And so as opposed to the sectors, which had 10 to 15 pages for their talk, I will be summarizing all 10 longer regions in a 12 to 15 minute talk. So instead of trying to cover every single region and all of the impacts and case studies from all the regions, I'll provide more context on the utility of the regional chapters and talk about two case studies of their relevance, really working with policymakers and how they can be used. As we already went over, there were 10 regional chapters in the NCA form, and they were really seen as the main course of this from a lot of stakeholders who were interested in really having information where it was that they lived. As Dave said, there were two new regions, so the U.S. Caribbean region and the Great Plains, which was separated into the Northern Great Plains and the Southern Great Plains. Really what I think makes the regional chapters so special is that the key messages in each of them are unique to the communities in that region. So the messages were determined by talking to stakeholders and interacting with people and experts that represented the values that were really being impacted by climate where they lived. So in order to for the National Climate Assessment regional chapters to support regional and local management decisions, there were really four things that the assessment had to be. Had to be authoritative, comprehensive, transparent, and inclusive. So we wanted this to not only be done by directly informing management, but also providing an authoritative synthesis of climate change and impacts to people in the place where they live. And so really these regional chapters are meant to support high-level decisions in the places where people are living. So for that effect, in terms of authoritativeness, there are hundreds of peer-reviewed studies in all of the regional chapters. The entire process was transparent. It was open to the public. You can go and read every single comment that was made on each of these chapters. It was comprehensive. It included all of the stakeholders in every sector across the U.S., and it was inclusive in that there was broad stakeholder engagement at every step of the process. So just to get a little bit about the policy for a minute, and what exactly is a national climate assessment? So for many federal scientists who have worked on this and who are sitting in this audience, this is just a box that you might check every time you publish a paper. What is a highly influential scientific assessment, which the National Climate Assessment is? But for local decision makers, it's more than a box that you check. This is a single source of authoritative information to cite, which represents a synthesis of all the knowledge at this moment in time about climate impacts on the regions. So a highly influential scientific assessment, or a HISA, is quoted from the OMB as saying it's scientific information that will have or does have a clear and substantial impact on public policy or private sector decisions. And so what is influential scientific information? It's classified as having more than $500 million worth of impact in any given year on the public or private sector. So by definition, this report and the sectoral and regional information has this influential and authoritative classification. In terms of inclusivity, I can only speak in detail for my region, but I wanted to give an example of the type of process that went into all of these regional chapters, as was mentioned through the regional engagement workshops that were held across the country. So in terms of what happened in Hawaii and the U.S. affiliated islands chapter, before the chapter was even written, we did a sectoral survey in which we asked people what sectors they were most interested in seeing addressed, in which we had 136 respondents. We had a series of webinars in which people were invited to contribute authors for the report and to identify regions that are sectors that they were most interested in seeing represented. We had a 2-day series of sectoral workshops where we got as many experts as we could in the room and really drilled down on modifying our key messages for the chapter. And we had 2 engagement workshops or town halls, one in Honolulu, one in Guam, with about 70 and 40 participants respectively. So just in our chapter, we had over 350 people engaged in the creation before we even really started writing the chapter. And if you multiply this across the 10 regions, it becomes a lot of people that really had a lot of input in shaping these chapters. I also wanted to look across the regions at the different key messages and really see if there were themes that emerged looking across them. So what became clear as I looked at all of the key messages were that impacts are currently and will continue to negatively affect economy, infrastructure, coasts, ecosystems, natural resources, and human health across the regions. As I looked at the key messages, 10 out of 10 of the chapters discussed adaptation, 9 out of 10 mentioned the economy, ecosystems, and human health, 8 out of 10 addressed rural livelihoods, natural resources, and infrastructure, and 7 out of 10 discussed vulnerable communities, extremes, or heat. So now I'd like to go into 2 slightly more in-depth case studies that are regional examples of adaptation and collaboration, and how these chapters can be used for decision makers and decision support, and can be used as examples for other communities. So the first one, very far away from Hawaii and the Pacific Islands, is the Northern Great Plains. I was really impressed with this case study. So the Northern Great Plains is essential to U.S. food security. It represents over 23% of U.S. land and farms, over 21% of beef cow livestock, over 30% of conservation or wetland reserves, and although it's only 1.5% of the population, it's over 12% of the agricultural product market value. In the Northern Great Plains, managers are used to dealing with highly variable climate conditions. However, currently and projected in the future, as you can see in this figure, looking at changes in the number of very hot days and days with precipitation exceeding 1 inch by the mid-21st century, there are increasing extremes outside the historical range. And so because of this, the managers that are in the Northern Great Plains need to increase their flexibility to deal with these systems. So what the Northern Great Plains has been doing is adaptive rangeland management to really make better decisions under increasing climate variability and increase their resilience. What they've been doing is something called grass banking, in which ranchers, landowners, and conservation groups collaborate together for an adaptive strategy. In terms of variable precipitation, it makes it difficult for managers to balance forage availability with animal demand. And so in this collaboration, in the grass banking, ranchers lease land from property owners at a discount for ecological management and joint management grazing plans being developed every year. In 2017, this meant that 280,000 acres of public and private land was jointly managed, and this resulted in 340,000 acres of improved habitat across the region, which is important for threatened species like the sage grouse there in the lower corner, which you might have heard about a lot in the news recently. Also, as a result, sustainable ranch operations are able to be more resilient in a changing climate. Next, I'll go someplace a little more familiar, Hawaii, and talk about a case study really looking at sea level rise and infrastructure management in Hawaii. So in 2017, the state of Hawaii adopted sea level rise planning projections of 3.2 feet by 2100. What this map highlights is the potential economic losses associated with that 3.2 feet of sea level rise to land and infrastructure. Losses in the dark red, so the warmer colors, range from $50 to $150 million to land, residential, and commercial infrastructure. Other places on this map that are circled that you might want to pay special attention to are highly impacted areas, including Pearl Harbor, which is the headquarters of U.S. Indo-Pacific Command, and Waikiki, which is the economic tourism engine of the state. What this means statewide really has a large impact, a large economic impact. Across the state, more than $19 billion of losses are projected from this flooding. In addition to the infrastructure being impacted, 550 Hawaiian cultural sites will be lost, and over 20,000 residents are projected to be displaced. As a result of this study, the state of Hawaii and the city of Honolulu created advisory climate commissions in 2016 and 2017. This resulted in 2018 with a mayoral directive for Honolulu county agencies to start planning for sea level rise and incorporate these decisions, or these sea level rise projections into their decision making and planning. So in terms of the use of the regional chapters, something I've heard while talking to different people is the question, how is this report different from the myriad of other climate reports that are coming out, and really how can it be used? So firstly, as I went over before, it is a highly influential scientific assessment. So by definition, it's policy relevant to communities in the United States, and it's not policy prescriptive. Local governments need information now to help guide future policy frameworks. And as we talked about before, it really reflects what these communities value about the places they lived. Finally, I think the most important thing that comes from these regional chapters is that the regional information should empower cities and states to act. Cities and states need authoritative climate projections, and they need to really enter into the debate of how to best adapt and how to counter the impacts of climate change, not whether they're happening or exist. Regional chapters make this point and provide examples from communities. For example, 3 days after the National Climate Assessment was released, so it was released on Black Friday, the following Monday, the mayor of Honolulu called a press conference down on the pier with 2 of the Hawaiian Pacific Islands chapter authors and our climate resilience officer to talk about the kinds of tough decisions that the National Climate Assessment brings up and that we're going to need to make in the future. 2 days after that, the state introduced the idea of carbon pricing and cited the National Climate Assessment Hawaii Pacific Islands chapter executive summary. So these are 2 policy impacts that have already come out of it. And finally, I'd like to thank the hundreds of volunteer federal and non-federal authors, editors, and technical contributors to the National Climate Assessment. And I'd like to encourage everyone to read about climate impacts in their region, as well as the other regions, to really get ideas of how to adapt and collaborate. Thanks.
Thanks, Victoria. It was fantastic, and it's good to see it already having an impact on the ground. Next up, and before we get into the Q&A, we've got Meredith Muth, who will be talking about climate effects on U.S. international interests, a new element of the National Climate Assessment.
Need sunglasses. Can anybody see me? No. What a sensational panel. Thank you. So as David mentioned in his opening remarks in the overview, international was identified as a key gap in previous assessments and an opportunity for the 4th National Climate Assessment. But what does this mean? What is international as a gap? We already have international scientific assessments. IPCC has been mentioned. What we mean in terms of the NCA is that we know that weather and climate cross our borders, but so does people and goods and services, and we're in just the connectivity between the United States with the global community is becoming stronger and more expansive. And so it's really important that we include that connective tissue into the National Climate Assessment. Oh, thank you. And so based on that feedback, the framing that we use to integrate climate into this assessment and to integrate international context is that U.S. interest can be affected by climate-related impacts that occur outside of the U.S. borders. So what happens outside impacts U.S. interest here in our country and abroad. And so we address this in 3 different ways. The first one was that we have a separate annex that actually outlines other countries that are currently doing their own national climate assessments. That was really informative. Second, you'll notice that 9 out of 10 of the regional chapters share either land or maritime borders with other countries. And so there's integrated throughout the report, you'll find mentions of working in collaboration or impacts from the international community in the regional and sector chapters. And then third, we have a standalone chapter, Chapter 16, which is exclusively focused on climate effects on international U.S. interest. And this wonderful author team focused on 4 different areas: economics and trade, international development and humanitarian assistance, climate and national security, and transboundary resources. And so this presentation will walk you through these 4 areas, addressing some of the risks to U.S. international interest, as well as some of the actions being used to respond to those risks, in particular drawing from throughout the report. So the first one is economics and trade. The impacts of climate beyond our borders is virtually certain to increase U.S. trade and economy. And I'm using the word virtually certain because that is the language that the authors used in the report. Now, how does this happen? In many different ways. For example, many U.S. businesses have their operations or some parts of their supply chain that are based overseas. That could include mining, it could include transportation, manufacturing, et cetera. And when an extreme event occurs in that location overseas, it can have significant disruption to U.S. businesses. We use one example here. Western Digital manufactures hard drives. 60% of those hard drives are manufactured in Thailand. A flooding event in Thailand in 2011 led to nearly $200 million in losses, as well as significant reduction in what was being able to be shipped in terms of products, and it also had temporary effects on the global prices for hard drives. And so this is just one of many, many different examples. In addition, import and export prices. So it is anticipated, highly anticipated, that climate will impact the availability and the prices of many different commodities, agriculture, energy, and other services, and that, of course, will impact U.S. businesses. So what are some examples of actions to reduce this risks? Well, increasingly, U.S. businesses are recognizing and reporting on these climate risks very publicly. For those of you who attended the public forum yesterday with Lisa Jackson, she spoke about how Apple is taking steps to manage and mitigate environmental risk to their supply chain. And in the report, we provide some really interesting examples of how the private sector is working with environmental organizations as well. So, for example, there's several. Conservation International is working with Starbucks to build up capacity of coffee farmers to manage climate risk. So that helps kind of build resilience for one part of their supply chain. So the next topic is international development and humanitarian assistance. So developing countries are often highly vulnerable to climate-related impacts, especially extreme events, because it can really slow down or reverse development progress. And this is important for the U.S., because it undermines many of the investments and work we've done in partnership with countries to build up development, and it also increases the need for humanitarian assistance and disaster relief. So 2 examples. The top picture is Hurricane Mitch from 1998 in Central America. The bottom picture is Typhoon Haiyan in 2013 in the Philippines. Both of these, the U.S. was actively participating in efforts related to humanitarian assistance and disaster relief, including our military. And in terms of long-term planning, these types of events have redirected how the United States redirects some of our development work to help address recovery, long-term recovery, and make up for development that has been lost in the process. Now, there are many examples of how the U.S. is working with the international community and other countries to better prepare, plan, predict, respond to extreme events and climate-related impacts. This is just one example I thought I'd highlight if you weren't aware. The Famine Early Warning System Network. This was developed in 1980s, led by USAID in collaboration with other key agencies in the United States government, working currently with 34 countries, governments, partners, to provide early warning, anticipation of food insecurity up to 6 to 12 months in advance. And this was, in particular, really helpful recently in 2015 when Ethiopia had one of the most extreme droughts on record, and it helped give advance notice and planning so that they could be prepared to address food insecurity and famine in that area. Now, moving to the third is climate and national security. And now there's many different ways that these 2 issues interact. I've sort of touched on one of them, which was how the U.S. military engages in relief efforts. Directly, climate can directly impact military installations and infrastructure. More indirectly, climate can impact factors such as food security or water availability that could then exacerbate climate abroad in other countries. I would like to focus on that first aspect because it was in fact addressed in multiple chapters across the assessment. So climate is already impacting many U.S. military installations and infrastructures. That includes roads, runways, and in particular those that are located in coastal areas. There's a picture here of the Naval Station in Norfolk, Virginia, not too far from here. very low-lying, very vulnerable to sea level rise. Now, what type of actions are happening? The Department of Defense is currently trying to understand where the risks are and how to best incorporate climate change into long-term planning. And there are several examples provided in this report. One right here on the right is the results of a survey that was done to assess all of the Department of Defense's assets and determine where climate vulnerability exists. A second example was related to a more in-depth look at those coastal installations, including the Pacific atolls, on where, on how sea level rise scenarios overlap and where the highest risks are and for planning. And now the last area I'd like to talk about is transboundary. We included transboundary because weather and climate and extremes span our borders. On the left is a picture of the drought in 2011 that you can clearly see does not obey any of our political boundaries. There was a lot of collaboration between the US and Mexico during that time. But in addition, we have impacts that cross our boundaries. On the top is a picture of smoke plumes coming from British Columbia moving into the United States. So it's from the wildfires. And on the bottom is just a reminder for me to mention that there's been an increase in the introduction and reintroduction of vector-borne diseases into the United States, especially from the tropical areas. And while climate is not the only factor leading to this, increased temperatures is likely. What's the word? I'm looking at Chrissy by now, but it certainly is likely contributing. And there's a couple of case studies on this inside the report. But what I really want to focus on is water resources, because shared water, especially with Canada and Mexico, rivers, lakes, including the Great Lakes, have direct impacts for our U.S. communities, social and economic impacts. And many of these are highly vulnerable to different climate issues, and they're talked about in multiple chapters in the report. And so collaboration, working with these countries on these shared water resources are important for issues such as mentioned here: irrigation, drinking water, power generation, flood risk management. Now, there are complex laws that govern the allocation of water between these countries. In Chapter 3, in the water chapter, they identified that close collaboration, transboundary collaboration, is really important to sustain adaptive water management and include climate components. And so the good news is that this is actually happening quite a bit. We are increasingly seeing climate information being captured in the management of shared water resources, and here's 3 examples. On the top, along the Canadian border in Columbia River, climate scenarios are being incorporated into watershed and water flow models. In moving towards the southern border, in the Rio Grande, Georgia, some really interesting public-private partnerships going on right now that include the local resource managers and academia working across border to restore and manage and sustain these water resources so we could have all of those issues above, such as irrigation, et cetera. And finally, in the Colorado River, the International Boundary and Water Commission is in charge of implementing the water treaties between the U.S. and Mexico, and they are working now to incorporate adaptive management that includes climate risk into those plans. So in addition to working regionally, both with Mexico and Canada, there's active collaboration going on both in the Caribbean and in the Pacific Islands as well. Very important for adaptive capacity. And this picture right here is just an example from Chapter 20, which is the Caribbean chapter, which had a whole key message just on international cooperation to support adaptive management. And with this audience here, I would have to also mention the importance of international collaboration, in particular on science. I believe we have 101 countries here at AGU this year. It's absolutely essential that the U.S. continue to work with our global partners on science, those underlying the underlying processes to observe, understand, assess. The more we work with our partners, one country can't do it alone. Our chapter also identifies very concrete benefits that international science collaboration has brought to the U.S. And so in conclusion, it's always good to end with an alt-text slide, but the word we used in the chapter was that there is high confidence that climate is impacting U.S. international interest. Where we don't have that high confidence is in these couple of emerging areas. Complexity was mentioned quite a bit, and there are a lot of complex issues, but understanding the mechanisms by how these impacts are happening to affect U.S. interests, but also the effectiveness of the adaptation actions that are happening right now. These are areas that I'm hoping NCA 5 in 4 years will give us a little bit more information on. And to end with one of the key findings of the report, which is we're really happy to see that actions are being taken, but it is still highly unlikely that the measures implemented so far will fully avoid or offset the adverse impacts to U.S. international interest. And with that, I thank you and all of the amazing authors on this team.
Thanks, Meredith. If I could invite the authors to come up here, we'll have an opportunity for some Q&A. I'll do my best to spot you out with the blinding lights in my eyes. So just give folks a minute and prepare your questions. And please do state your name and affiliation. We've got, this is being live recorded, so it'd be great for folks watching remotely to know where you're coming from. And Meredith could always just stand up if the monitor's blocking her. Yeah, right here.
Michael Wader, Puerto National Laboratory. I have a question about how much climate change is costing us now. We've had a number of very expensive, multi-billion-dollar events: Harvey, Maria, Irma, Sandy, goes on, fires in California. All of these have clear attributions to human influence on their severity. Does the report talk about these kinds of events and what climate change is costing the United States in 2018?
Sure, that's a great question. Is this on? Yes. Sure. The question was, what does the assessment report tell us about the cost of extreme weather events happening in the U.S. today? And I think sprinkled throughout the report are a number of economic metrics talking about the costs of recent extreme weather disasters and events, primarily relying on the Noaa billion-dollar database. So if you're not familiar with that, I would definitely suggest checking that out, as well as some of those numbers that are cited in the report. I haven't seen many good numbers of, what is all of that totaled up. And I haven't seen many studies. A lot of the studies out there in the economics literature focus on, projections into the future rather than an accounting of, the climate attributable damages occurring today, which each of those questions, the future versus what's going on today, have their own sort of constraints and uncertainties. And the one, answering the question of, what's happening today also requires a lot of those attribution questions, which is an evolving science.
Are you going to use a microphone or not?
Oh, I'm sorry. I couldn't even see that there was one. My apologies. Understood. Yes, thank you. And just to complement the response to that question, in the end of the overview, there is a kind of set-aside box that articulates what has happened since the last assessment, a portion of which is an enumeration of a number of these billion-dollar disasters. And so there is some accounting, but it doesn't necessarily get into the actual, say, anthropogenic induced cost component, which I think is obviously an area of interest going forward. And apologies, yes, at the mic, can you please state your name and your institution, please?
Hi, yes, my name is Francie Deep. I'm a writer for Pacific Standard magazine. So one thing I had a question about was, you guys mentioned there were stakeholders who'd asked for the local chapters, for the international chapter, for the economic assessment. Can you tell me more about who exactly those people were that asked for these things. And also, I was wondering if you could give some more examples of entities that have already used this report, such as like the Honolulu Mayor example. Thanks so much.
I can take it first, and then I'll pass it over to folks. In terms of who informed this report, I mentioned briefly, but I would direct you to, I believe it's Appendix 1, the process appendix. But we really talked there about a lot of the public calls for information and for feedback. And so, whoever we reached, whether it was through the Federal Register notice, through agency listservs, and frankly, beyond whoever receives those things after we send them out initially. We received scores of inputs in the initial draft prospectus phase, and then, like I said, during the public comment phase, there were, I think, over 1,000 registrants that sought to get the report. Obviously, the comments that came in from them, as well as the national academies, of course, certainly had a shape into what went on. But some of the chapter authors may be best positioned to speak specifically about their sectors and regions and the types of folks that they hit.
I'll just I'll add a brief addition. You already heard about the Hawaiian Pacific chapter and a lot of the different stakeholders we engaged. But a way that we reached out to as wide of an audience as possible is through existing networks that we had through the Noaa Pacific RISA project, which is a very stakeholder-based project, and we used a lot of the networks we had developed through that project over the past decade, as well as through the university partners, through our decision-making partners in state and local government. We had farmers represented, we had landowners, ranchers, water managers, people at really all sorts of both decision-making and public areas.
Anybody else want to chime in? Chris?
That's true for all of the chapters, that we reached out to networks, we reached out through professional networks to find folks who would like to provide input into issues to cover in the chapter, reached out to make sure that people were aware when there were opportunities for providing expert input. So there was a very active process for engagement with a broad range of actors depending on which sector we're talking about.
Thank you. Next.
Oh, and what about examples of entities that have already used the report?
My apologies, yes.
Oh, it's okay.
I know Victoria had a couple of examples. Does anybody else have any near-term examples? Granted, it's only been out for 2 weeks, but...
I think it's pretty unusual that we already had 2 examples and it's been out for 2 weeks.
Well, one thing I will say is that we do know that there have been folks who are already starting to take that information and turn it into school curricula for middle school, high school, college-level classes, and one of the things I think we pride ourselves on with this assessment is that it's written in an accessible way, but has the rigor of a traditional scientific paper, and so it really can hopefully span as many audiences as possible.
Thank you.
Thanks.
Bob Ward from the Grantham Research Institute at London School of Economics. I want to ask about the economic assessments and how confident you are that you've managed to capture the biggest potential impacts. For example, your figure that you would only reduce the GDP of the United States by 10% if you had global warming of more than 5 Celsius degrees seems a bit incredible. That's just the equivalent of reducing your annual economic growth rate from 3% to 1% for 5 years. So there's a lot of concern in the research community that these models are simply not fit for purpose. So can you, for instance, did you include tipping points, for instance?
Right. It's a very important point. Obviously, with an assessment, you're limited to what has been produced. We don't produce new sciences or economics as part of this process. While there was an advancement in economics, as I'm pretty sure you're aware of in the climate space, we are limited. And one of the main limitations of not only individual studies as well as these multi-sector impact projects that I mentioned, of which you saw 2 of those slides, is that they're incomplete. We know, and both of those projects try to be pretty explicit, I think, that there are important impacts that are not included. There's also impacts that may be valued but are only partially valued. So that multi-bubble graphic I showed, for example, wildfires was one of the sectors in there. However, the valuation was just on the wildfire response costs, not on the fine particulates that cause air quality, health impacts coming from those fires, and so forth. So I think it's important. I look at this as a double-edged sword. On one hand, it's an important process for this assessment to begin to put those numbers out there and to state them with the uncertainty and the confidence levels where that is appropriate to that science, but also recognize that this is a literature that needs to expand significantly to inform this debate, because at least in my opinion, the economics is an important and powerful part of the policy dialogue and policy development process, because I think people see action on emission reductions as a large cost to undertake, and in my view, what's missing from a lot of at least Americans' viewpoints is climate change is going to hit our wallets, and each and every one of our wallets in very significant ways, many of which we don't understand yet. And so, the more that literature grows, I think the more, hopefully, this assessment can communicate to people.
My name is Noel Gerwick. I'm at the U.S. Agency for International Development. Thank you all for such a well-crafted and clear set of presentations. I have a question, but I first have an observation that might not be apparent to everybody, is probably apparent to many people in the room. The administrative and bureaucratic wrangling of this report is a Herculean task. Many times the buck stopped on David's desk, and I really think he deserves a thank you from all of us. So my question is first for Victoria and maybe for other people. The Honolulu, Hawaii mayor example was obviously captivating. It's hard to listen to that example and not wonder, how did the relationship develop between the authors and the mayor, and did it really happen over Black Friday and the next 2 days, or is that something that began actually quite a bit earlier? And so, this report is full of lessons on engagement of science and any number of stakeholders. So I'm curious if you have any additional insight into how that particular relationship developed, how long it took, and then whether any of you are aware of other examples of ways that authors or members of author teams have created those kinds of relationships or nurtured them.
Thank you for that question. And we actually have a talk almost exclusively about kind of the interplay between those relationships at the city, state level with the National Climate Assessment and with researchers, and how those connections are made. Tomorrow, Zena Grekny will be giving a talk on a regional example about that, and you can hear more from her. But in terms, you're right in noticing that didn't just happen on Friday. They saw it. They called us up on Sunday, and we showed up. So two of the authors, myself and Chip Fletcher, the authors of the report, are also on the Honolulu City Climate Commission for the last year. So we've sat on that commission and have been very active in working with the Honolulu City Council and the Honolulu mayor in working on sea level rise issues, as well as a host of other things. But I think in Hawaii, we're lucky to have a set of researchers that are really stepping outside of strict research world and really starting to work in that boundary space between climate policy and climate science more aggressively, and it's really making a difference in the way that we adapt.
Thanks. Next question, please. Thanks.
I have to preface my comment by saying that I did not really study the report, sufficiently. Mm-hmm. However, I sat down and I listened to all the presentations, and I agree with a lot of the assessments that that have been described. However, the issue of assessing the impacts of climate change as we move from global to regional and local scales becomes much more complex, much more uncertain. And the impression I got from the presentations, I had to wait to the last slide of the last presentation to get statements about things that we don't know and things that are not well understood. I think it would help the process significantly if, in addition to pointing, for example, as I agree with what has been discussed, that some of the models' projections are really underestimate of what could happen. And there are good examples for that. Climate change could have more impacts, more serious impact than what models are projecting. There are also things that people observe and attribute to climate change that are not really caused by climate change. There are processes and phenomena that's out there that we don't understand enough to be able to tell at regional and local scales. And so we have to balance our message, I think, in general, so that we could maintain this credibility, which is very important for this process for the longer term. And so the impression I got from the presentations today left me wondering about, many of those phenomena that I know that we don't fully understand yet, and we need to do more research on them before we could assess them at local and regional scales. And many of the things that I think are unrelated to climate change that sometimes people attribute to climate change. And so I would be interested to see the reaction of the panel to those.
Sure. No, it's an entirely valid concern to have. One of the things that sets apart USGCRP assessments from almost any other thing out there is that we have a whole component of the report called traceable accounts that authors probably both love and hate, in the sense that basically what it is it gives, it forces the authors to kind of, look under the hood, so to speak, and gives the author, or the reader, a look at the deliberative process of the authors. And so, that you restate the key message, this time with the calibrated uncertainty language that we adopt from the IPCC. But all of that is actually supported by a characterization of the uncertainties, an identification of research gaps and areas of that lack understanding. And so if you go to the end of each chapter, you can see those in detail, and you can certainly access it on our website. And if you go to our booth, you can actually, we have a couple touch screens that I'd be happy to help to navigate them with you and give you a sense of exactly how that looks. I don't know if the authors have anything to add. Yeah.
In addition, don't discount the reviewers. The reviewers are critical to the process. Reviewers put in so many hours checking each statement, checking the references underlying statements. We get very detailed and very helpful comments. There's also review by the national academies, and they assign quite a wide range of reviewers to go through each chapter to check each statement to ensure that the traceable account is honest, it's unbiased, it presents the best quality science that we have. And so things are presented with what we know and what we don't know, what we have confidence in and where we need more research. So it is an extensive process. It's not just, the result is not just from the authors, it's from the authors and the reviewers and from the national academies.
I'm not questioning the process and how you have checks and balances in it, but however the message that comes out, I think necessarily should, in addition to pointing out assessments and things that climate change we think is impacting, also to highlight areas where we don't have the understanding, areas where we think the assumptions about things related to climate change are not true, and so to balance the message so that the objective reader of the report would have the confidence and that would maintain the credibility for the longer term, I think.
Thank you.
Hi, I'm Brenda Hoppy, and I'm a research scientist with the Minnesota Department of Health. And I just wanted to put a human face, I guess my own, to a comment that Victoria said. And I nearly bum rushed the stage to give you a hug, Victoria, when you said that states and cities need climate projection data. And forgive me if you've heard me stump around the conference before with this point, but I'm going to vocalize frustration from many, many folks, city and states across the country, that we desperately need climate projection data and not the stuff that's available. I thank you, USGS, for the National Climate Change Viewer. There are other portals out there where you can grab data. It's not what we need. We need downscaled, high-quality, reliable climate projection data. And if you want, trust me, if you want climate resiliency advocates and innovators, that happens by democratizing this climate projection data, get it in the hands of people that, the civil engineers, the public health researchers like myself, planners and so forth, and they need to get that data in their own wonderful, brilliant hands to do the work that's necessary to really get this nation going on climate resiliency. So I'd just like to ask, from your points of view, situated in the federal government, what kind of efforts are going on? I'll say in Minnesota, everybody's scrambling to try to get these data. We know it's expensive, but the feds are much better equipped and much better resourced than those of us at states and cities to get this data. So what kind of movement's happening along those lines?
It's a great question, and certainly recognize and appreciate the fact that the federal government has an important and unique role to play in this space. I'm not sure if you're familiar with it, so apologies if you are, but the Noaa Climate Resilience Toolkit in particular is one of the biggest efforts that the federal government has undertaken over the past couple of years to try and provide some of that information. In particular, if you go to the Climate Explorer aspect of that, you can basically type in your zip code or your city and get climate projections under a couple of different scenarios through the end of the century for a number of different climate variables, both largely temperature and precipitation related. But that's certainly one thing. And one thing we tried to do with the National Climate Assessment is to really make that linkage more cohesive. And so if you look at some of the figures in the report, you will actually see an icon that looks like a couple of gears that sort of directs the reader to the Climate Resilience Toolkit. Sometimes that appears where there are case studies, because there are hundreds more case studies of adaptation actions in the Resilience Toolkit that we want people to be aware of, but we simply didn't have the room to put them in the assessment. In other cases where there are quantitative plots, we make a link to say, hey, we show an example here for, say, Phoenix, but you can do it for Duluth or anywhere else in the country as well. So it's a first step. I would love to talk to you more about what you think some of the needs are so we can try and help satisfy them. Yes.
I'd like to tie this comment with the comment from the previous person. It's not just climate. Climate doesn't drive all of these particular outcomes. It's an interaction of the hazards created by a changing climate, who or what's exposed to those hazards, and the underlying vulnerability and capacities. And so, yes, you do need downscaled climate data, but you also need to have a much better understanding of what the range of possible futures are, what urbanization might look like, population growth, GDP, to get a better sense of who or what's going to be particularly vulnerable and what the options are, how we can create more flexibility so we'll have more options in the future, so that we can take action proactively and we can build that resilience. And so don't forget that there are other data. And unfortunately, those data are not as well developed, that we don't have a good process in the United States for collecting information on vulnerability. We know how many people there are, more or less. We know where they live, more or less. But really getting at vulnerabilities is a much more difficult issue. And it is an area that will become increasingly important as the United States is affected by, for example, increases in the frequency and intensity of extreme events.
Thanks, Chris. We're about out of time, but I do, again, want to thank everybody for attending. I want to thank the 300-plus authors who volunteered an enormous amount of time over 2.5 years. And note that while we don't have any additional hard copies in the room, we do have some at the USGCRP booth. If you go into the exhibit hall, head to the back right corner, the beer stand back there, you'll find us. Engage us. We'd love to talk more. Again, huge thanks to our panelists, and huge thanks to everybody else.